couple of years ago, I started a dream job. I would be doing what I love, coding and building software. And what's even better, I would be doing it in Ruby. The first 6 weeks of this job were absolute bliss. I was working on a relatively new code base, a code base that had some rough patches, to be sure, but the vast majority of it was very maintainable and very understandable. Now, during this time of bliss, I did hear whispers of another code base. A code base so terrifying even the bravest developers fear to tread there. This was 40,000 lines of gnarled, nasty, snarled, largely untested legacy code. Now, I figured I would be introduced to this code base in due time, piece by piece. But as always, the unexpected occurred. The only other full-time developer at the company left. And suddenly, this legacy code base was my responsibility and mine to tend. My days of bliss turned into days of receiving a frantic bug report, panicking, writing a fix as fast as I could, deploying that fix, and breaking more things and panicking again. This cycle would repeat over and over and over. Test-driven development wasn't a part of the equation at this point. I felt it was taking all my time and energy just to keep this system above water. I didn't see how I could incorporate tests into that. Now, scared as I was of the bugs that I did see, what scared me the most were the ones I knew I didn't see, the silent bugs lurking in the depths of this legacy code. Now, during this time, I once woke up screaming. I had dreamed I had been working on this legacy code base on my laptop when all of a sudden the code turned into a mutant bat and flew directly into my face. Scared the heck out of my fiance. This code was invading not only my conscious mind, it was seeping into my unconscious mind as well. It felt dark. It felt hopeless. It felt like an endless night that I would never escape. But dawn did break. I don't wake up screaming anymore. I don't dread opening up my inbox in the morning and having to sift through the deluge of errors and exceptions that came in overnight. I used to feel like I just coded to apply Band-Aid fix after Band-Aid fix to this legacy code base. I actually build things again. I do what I love again. I want to tell you a story. A story that starts with love. A love for code. A love for building software. Now, this love is severely tested when I inherited this legacy code base. And I actually passed through the 5 stages of grief. Denial, anger, bargaining, depression, and finally acceptance. I also want to share how this grief turned into love again. A love that is more passionate and stronger than it ever has been before. Test-driven development was the key to learning to manage my grief, moving through my grief, and learning to manage this legacy code system. It didn't happen overnight, and it certainly wasn't easy. Even now, after working as a test-driven developer for some time now, it's still not all unicorns and rainbows. I still have to work at it. There are still rough patches, and there is change. But the difference is now those changes are not insurmountable. So who here has had to deal with legacy code? Just about every hand went up. Does that code ever scare you? Does it haunt your dreams? I want to share my story to help you move beyond the grief, the anger associated with legacy code, and rediscover the joy in coding. You can tame a legacy system. I'm here to share how. After I inherited this legacy code, I found myself at the first stage of grief, denial. Now, this legacy code base had some tests, but the vast majority of it was completely uncovered. I was relatively new to test-driven development when I started this job, and I'd only tried it on greenfield applications. I thought that it wasn't the time to try adding it to an existing application. I was getting errors and exceptions left and right. I felt I had to stabilize the code base first and then worry about tests. To do this, I resolved to stick to manual testing for the time being. I would code a fix, test it manually, deploy it. If that fix broke things, I would code another fix, deploy it again. And if that broke more things, I would code another fix and deploy it yet again. The problem with this approach was I had no way of knowing if I changed one class, whether that change would affect 2 other classes, 3 other classes, even 10 other classes. With every deploy, I was flying blind, and I knew this. But I still thought I would add my tests when the crisis passed, when I had a moment to breathe. I convinced myself I just needed to hold out a little longer. Surely things would get easier soon. Surely then, only then would I have time to add tests. The truth, though, is a magical, better time in the future never comes. Every untested line of code I committed only made the system worse and spiked my stress level even higher. Kent Beck writes in Test-Driven Development by Example that the more stress you feel, the less testing you will do. The less testing you do, the more errors you will make. The ideal time to write tests is not some magical time in the future. The ideal time to write tests is always now. Now, I could only stay in denial for so long. I knew things were falling apart. I even knew that adding automated tests would be a way to make it better. But I didn't know where to start. Any bug fix, any new feature I added, depended very heavily on untested legacy code. Writing tests seemed impossible. How could I write tests for someone else's code? Even someone who had left the company years ago. How had the code even gotten to this state? I honestly started to get angry. Now, has anyone else looked at legacy code and felt angry? Did you think to yourself, what was this developer thinking? I would go in circles in my mind, ranting and raving about the sins of past developers. Why did I have to clean up their mess? Why was it my responsibility? Fortunately, someone pointed out to me that the truth is the past developers were probably just as panicked as I was. Does anyone really write bad code just for the sake of writing bad code? Does anyone write untested code just for the fun of it? I could rant and rave about the past all I wanted, but it wouldn't accomplish anything. The truth is, you simply can't change the past. I couldn't go back in time and write the legacy code better or prevent it from being written the way it was. I needed to move forward. It turned out the thing that needed to change the most wasn't actually the code. The thing that needed to change the most was me. I needed to take ownership of this code, as ugly as it was. I could curse the past day in and day out, but the only thing I could do was affect the future. The only thing I could do was make it better from here on out. Now, it is possible to add tests to legacy code, but it does take time. The problem with code that was written without tests in mind is that often it's untestable. To be testable, it needs to be refactored. And refactoring a working code base, particularly one that doesn't have test coverage to begin with, is always risky. Nell Shamrell writes in Rails test prescriptions, take small steps that can be verified. I couldn't add test coverage to this 40,000 lines of code all at once. This wouldn't be practical from either a technological or a business standpoint. But there were certain steps that I could take. Any new code must have tests. Now, when I read Rails test prescriptions, I found a pretty good piece of advice. which was to separate my new tested code, put it in new tested classes and methods, and call those tested classes and methods from within my legacy mess. Now, this is actually the first step in refactoring that legacy code, separating things out. Bugs in code must be reproduced with a test. Now, the way I found to do this, because that honestly is much easier said than done, was to use the bug report. Now, when a user submits a bug report, if they're nice, they'll include steps to reproduce that bug. What I did was use these steps that the user uses from the graphic user interface to figure out how to reproduce that bug on a code level. So let's say my user gave me a bug report, and it stated that when that user visited a form, let's say it's a form for a new record in the database, a new widget or something. When they visited this form, they would leave a certain field blank. Then they would click Submit. Now, when they did this, the application would crash completely. How to do this in a test was create a new object. Chances are a form is probably rendered by a controller, particularly in Rails code. One of the things that controller action does is create a new object in the database. I would then leave a field on that new object blank, save that object, and when I did this in a test, I found the test returned an exception. So this begged the question, what should my code do? Should it crash completely when a user just leaves a required field blank? Or should it return a useful error to that user? I tend to lean toward the useful error. So to do this in a test, I did this using the rspec test syntax. I created a new object, assigned that to a variable. I set a required field on that object to nil. I saved that object, and then I specified what I wanted my code to do. I wanted that new object to return an error, and I wanted to return that error to the user saying that a certain required field was blank. I then wrote the code to make this test pass. You can use tests to learn about legacy code. My tests let me interact with my legacy code directly on a code-to-code basis. Now, separate documentation might lie. Comments in code might lie. But exercising the code itself doesn't lie. With every new test I added, I learned more about this legacy code base. When you're adding tests to existing code, it's okay if those tests have an extensive setup. The point is to learn about the system. The more I learned about this legacy system, the more I saw how I could change it for the better. Now, once I realized I could add tests to my legacy code and use these tests to improve the system, my anger dissipated. I wasn't done with my grief yet, however. I moved on to bargaining. Now, I embraced the need for tests, but I was still in the middle of a crisis. Bugs and exceptions were still coming in left and right. Urgent bugs that needed to be fixed now. I decided to fix the problem first, write my code first, and then write my test. After all, how could I write tests for code when I didn't know what the code was supposed to do in the first place? Now, this is what I envisioned my workflow look like. I would write my code and then write my tests. It's a two-step process. In actuality, however, this process had many more steps. I would write my code, manually test that code, modify the code, manually test those modifications again, write an automated test, realize I had to modify my code to make the code testable, manually test the modifications to those code, and then modify my test to work. This actually wasted a lot of time. When you test last, it inevitably leaves holes in your test coverage. Now, when I did get to writing tests, I wrote them fully expecting them to pass. When they passed, I deployed. But the problem with this approach was that sometimes after the deploy, the code would break, but the test still passed. This was a red flag that something was very wrong in my approach to testing. I found this workflow works a lot better. I'd write a failing test, make the test pass, and then refactor the code. Chances are that looks very familiar to all of you. This is also known as red, writing the failing test, green, making the test pass, and then refactor. In Growing Object-Oriented Software Guided by Tests, Steve Freeman and Nat Pryce lay out the golden rule of test-driven development. Never write new functionality without first writing a failing test. It's called test-driven development for a reason. When I test first, I'm forced to clarify my intention, define exactly what I want my code to do. Then, after I have a failing test in place, I write code to do that, to do my intention, and to do only that. Robert C. Martin, in his Clean Coder Screencast series, says that testing is about trust. Trust that when you write code and all your tests pass and you deploy that code, it won't break anything in your system. The only way to have full 100% trust is to have every line of your production code be tested. Now, the only way I've found to come even remotely close to this number is to write my tests first. When I write my test first and then make that test pass, I know my code is covered by tests. It wouldn't have passed the test otherwise. It was actually pretty disheartening when I realized this. When I realized that my attempts at bargaining and my attempts at doing things on my terms had failed. I moved on to the fourth stage of grief, depression. I felt hopeless again. Sure, I could write tests first from now on, but so much of the legacy code, including now code that I myself had written, would still be so bad. What was worse, that even tests I had written, or that other developers had written in the past, some of those tests were unreliable. There were gaping holes in their coverage because those tests had been written last. I found myself asking, what's the point? What's the point of adding new tests when so much of the code and existing tests would still be so terrible? I honestly felt like giving up. I felt like writing off this legacy code base as a lost cause that I unfortunately still had to use. Now, it sometimes seems easier to do this, just to give up and resign yourself to living with a legacy mess. But the truth is, it's not. Production code doesn't stay in stasis. You will have to add things, and you will have to change things to a system that's still in use. When faced with a legacy mess, you have two choices. One, you can add to the legacy mess, let the code get worse and let it rot and collapse in on itself. Or you can move forward. You can draw a line in the sand and make it better from now on. Every line of tested code is a reliable piece of code. Every reliable piece of code is a gift to yourself, to your teammates, to your users. Now, by this point in the story, I was not the only developer at the company anymore. There were several other people also working to tame this legacy mess. Every piece of reliable code was a step out of the mess. Every piece of tested, reliable code is a beacon of hope in the dark snarl of legacy code. By contrast, every line of untested code is an unreliable piece of code. Every piece of unreliable code only makes things worse for yourself, for your teammates, and your users. The legacy code may have been bad then, but if I kept on committed unreliable, untested code, it would only get worse. Like it or not, I now owned this code. I was steering its direction. As painful as it was, as tempting as it was to give up, it wasn't hopeless. It's never hopeless to start doing the right thing. Now, the right thing to do to save my sanity and the sanity of my teammates and my users was to test drive my code from now on. It was to move forward. At this point, I found myself at the final stage of grief: acceptance. I finally came to terms. I knew I would survive this legacy code base and that test-driven development would be critical to this survival. It was time to leave the past exactly where it belongs, in the past, and move on to a brighter future of code. It was at this point that I realized the true benefits of test-driven development. One, the most obvious, is that tests prevent breaking. Production code doesn't live in a vacuum. As I said before, you will have to add things and you will have to change things. Change is inevitable. What's not inevitable, what we can control, is how painful these changes need to be. Now, the most painful changes for me are when I make a change and it breaks something completely unrelated in the code. Has anyone else had that experience? I see a lot of heads nodding. When I have a full test suite, especially one written with tests first, it prevents this from happening. Now, even when I run that test suite and a test fails unexpectedly, if I'm running that test suite often, chances are I'm going to know exactly what change broke that test. The best time to fix something is directly after you break it. Now, this meant I could keep coding rather than constantly chasing down bugs. Testing, it turns out, didn't just keep my code from breaking. It kept me from breaking as well. Tests are documentation. They're living, fully functional documentation that's entwined with your code. Now, rather than keeping my documentation in a separate place, say a wiki or, God forbid, a Word doc, my tests were embedded directly in my code. I couldn't change one without changing the other. The documentation, was embedded directly with my code. Now, some of the hardest cases to debug are when the original developer's intent is unclear. How can I fix a piece of code when I have no idea what that code was supposed to do in the first place? Tests document the intent of the developer. They state in no uncertain terms that when the code receives a certain input, it should return a certain output or take a certain action. So let's look at some examples of this. I have my first test saying that when I call a method called tax rate and pass in the argument Seattle, it should return 0.095. The tax rate in Seattle is 9.5%. I don't actually know what it is in Augustine. This tells me exactly what this method is expected to do, exactly what input it should receive and what output it should return with that input. Now the next one, let's say I want to call a controller action. I want to say that controller action assigns a variable called new object as a new record in my database. It should not be an existing record, it should be a new record. I can also say, I expect that a certain method which saves this record to a database will change the table count by 1. Not by 2, not by 0, it will add 1 record to that table. Now these tests state exactly what my intention is with my code. Test-driven code is better code. Test-driven code is modular, loosely coupled, and has smaller methods. It's really hard to test something that doesn't have these attributes. Now, these are the hallmarks of good code. Testing doesn't just tell me to write clean code. It compels me to write clean code. Code that is maintainable, that is more readable, and all around better crafted. Finally, tests remove fear. When I have tests for my code, I can refactor that code fearlessly. I can try new ways of implementing the same functionality, maybe something I heard at a conference or something I heard in a user group or on a newsletter. I can constantly make my code better, and I can do this without fear. Even with this gnarled, nasty legacy mess, I could still improve the code. I could move forward rather than staying stuck in the past. It would be a step-by-step, piece-by-piece process, but I knew this code would get better. I would make it better. Now, I wish I could say that after I passed through these stages of grief, this legacy code and I rode off into the sunset and lived happily ever in test-driven developed bliss. But that wouldn't be reality. I would be lying if I said that testing ever truly gets easy. It does get easier, and you will see the benefits very quickly. But much like love itself, it's something that you have to keep working on. Now, about a year ago, I found myself completely baffled when it came time to test drive code that interacted with an external API. I knew I couldn't connect to this external API every time I ran my tests. This would be impractical at best and would get me banned from the API service at worst. I was convinced I had to figure this out myself. If I couldn't figure it out myself, it had to be impossible. Fortunately, a colleague pointed out to me that I didn't have to go at it alone. When testing gets hard, and it will, it's okay to consult a teammate. It's okay to do a search on Stack Overflow or a search in Google. And to learn from experiences of others. Once I managed to move past my ego and actually Google the problem, it turned out that many others had already solved the problem of test driving code that interacts with an external API. Now, what I expected my code to do was call a method on the API service. That API service would return a certain response, and my code would handle that response. It turns out that for testing purposes, it was actually irrelevant whether my code connected to the live API. The way to do this was using mocks and stubs. Now, mocks and stubs are hard. It took me a long time just to conceptually figure out what they actually do. A stub is a stand-in for an object called by your code. It receives messages from your code when it's under test and returns scripted responses, responses that you tell it to return. So under test conditions, my code would call an API method. That call would be received by the API stub. The stub would then return a scripted response, a response that I told it to return. Now, mocks are specialized types of stubs. In Eloquent Ruby, Russ Olson, who just spoke before me, I didn't actually know that until he started speaking, points out that mocks are stubs with attitude. So a mock acts a lot like a regular stub. My code will call an API method. That method will be received by the mock, or that call will be received by the mock. And the mock will return a certain scripted response. Now, what's special about a mock, as opposed to a regular stub, is that a mock knows exactly which of its methods should be called and with what arguments. If my code calls an unexpected method, my mock will fail the test. Mocks are much more specific than regular stubs. If their expectations are not met exactly, they will fail the test. Now, the answers were out there. I just needed to reach out. It wasn't just me and my code all alone in the universe. There's an entire community, an entire world of developers all working on, who maybe already solved the same problems that I was working on. Just as I need to constantly learn and adapt the way I code, I constantly need to learn and adapt the way I test. Test-driven development is evolving. New test frameworks come and go. New best practices are being uncovered in regards to testing every day, it seems. I recently read Practical Object-Oriented Design in Ruby by Sandy Metz, who also happens to be in attendance. The chapter on testing opened my eyes to how I can make my tests not only have better coverage, but be smarter. It introduced concepts that I had never even conceived of, even after working as a test-driven developer for some time. I know that I will never stop learning about testing, just like I'll never stop learning about coding. The way I code and test will change over time. But even with these changes, the core benefits of testing, preventing breaking, acting as documentation, and compelling you to write better code remain the same. Now, my relationship with test-driven development is not perfect. But no relationship, whether between two people or between a person and their technology, is ever going to truly be perfect. That's what makes it worth doing. That's what makes it rewarding. So test-driven development changed the way I code. It gave me new tools for dealing with a legacy mess. But even more than that, test-driven development changed me. It transformed me from a developer who panics in the face of legacy code to an actual craftsperson. A craftsperson who cares not that my code just works for the current moment, but who designs code, who builds things to last. A craftsperson doesn't just rant and rave about legacy code, but takes action to make it better. Test-driven development is developing beyond myself, beyond my immediate needs at the present moment. It's developing my code to handle change without pain. It's providing a safety net and a guided path for any developer who might come after me. Now, change is inevitable. We hold the power to make that change something we can manage, maybe even enjoy rather than something we dread. Test-driven development empowers us to do this. I better understand why I do what I do now. I love to build things that last, that people can add to and change over time. Now, this love was severely tested when I inherited this legacy code. I had to pass through the 5 stages of grief, but I did rediscover that love, and that love is stronger than it ever has been before. Coding is a major part of my life. It's one of the ways I'm leaving my mark on this world. Test-driven development helped me move beyond the fear and anger associated with legacy code. I no longer code out of panic. I code out of love. And love, ultimately, is what life is all about. I'm Nell Shamrell. I'm a software development engineer with Blue Box Inc. Thank you very much.